So this video is all about your law of mass action, of what that number represents. So law of mass action, or this is your equilibrium law or equilibrium constant. So equilibrium constant. You might see this as just K or Kc or KEQ. These all represents pretty much the same thing. And what this is that you probably have seen this standard equation is A plus B. Here's your equilibrium, C plus a big C plus a small d and a large d. And the equilibrium constant, I'm just going to use Kc, this is equal to your product. So to first understand this, you're actually just looking at the ratio of products over reactants. And notice I'm using square brackets because square brackets represent this concentration. So this is actually your concentration, or pretty much the same as your molarity. And molarity, remember, this is your moles per liter. So how you're going to look at your products is you're going to have your large C, that's your concentration. The coefficient becomes your exponent, and here's your large D, and using little d as your exponent. Notice that this is side by side so that they're multiplying by each other. So here's just to finish off what the basic formula for your equilibrium constant is. This is just your generic term to calculate that. So how do we apply this to actual reaction? You can see that this one, I'm just going to move this one over a little bit because you can't see the nitrogen. This is the Haber process. This is to synthesize ammonia. And you're mixing nitrogen gas and hydrogen gas, and you're going to get 2 moles of ammonia. So if we were to calculate the constant equilibrium constant here, Kc, this is just basically equal to my product, which is my ammonia gas. I have the coefficient of 2, so that goes into my exponent. Divide this by both of these, so N2 is going to be here. I have a coefficient of 1, so it's just an exponent of 1. You don't need to write that. H2 to the power of 3. So basically this is your equilibrium constant, and this will show, actually the number calculated from this will actually tell you if your products or reactants are favored. However, there is a little bit caveat here when you're writing your equilibrium constant. That is, you do not include the following states. So include the following states. So that's solid. Whenever you see this S, you don't need to include it, or liquid, because the concentration actually will not change for both of these. So you don't need to include it for your equilibrium constant. So for this one, because we have a solid for carbon, we're just going to go Kc is equal to include all the ones with the gas states, which is this one, and that one. And you can see that it's quite simple. You have H2O, and this one is gas for some reason for H2. I guess it's just a vapor, but that's your that's your equilibrium constant. Now, to understand the next part is, what if you were to have a Kc of 1? What does this mean? What if you were to have a Kc that's less than 1 and Kc that is greater than 1? Equilibrium constant. So just to remind you, equilibrium constant is your products, and that is divided by the concentration of your reactants. So you must have to ask yourself, reactants, let me spell that right. What happens, or what do you have to do in this equation to get Kc to equal to 1? Well, in order to get equal to 1, that means the products must equal to the reactants. So this is the products is exactly the same concentration as the reactants. That means at equilibrium. Remember, this is your equilibrium reaction. So this is all about when it's at equilibrium, you would have the same amount of products as the same amount of reactants. So that's when it's equal to 1. So what happens when your equilibrium constant is less than 1? So if you look at this reaction or this equation, what kind of numbers do you need in order for this to equal to less than 1? Well, that means that your reactants have to be bigger than your products, because if the denominator is bigger, that means it's going to be less than 1. So what that means is that if your Kc is less than 1, that means at equilibrium, which one would you have more of? Would you have more products? Would you have more of the reactants? Well, in this case, because the bottom number, the denominator is bigger, you would have more reactants. So at equilibrium, your reactants are actually favored. And then when Kc is greater than 1, then you can see that at equilibrium, you will have more products. So that's when your products are favored. So that's how you make sense out of the equilibrium constant, because it's very important to knowing how to understand this this number related back to what happens in your reaction. So that's a little short video on calculating your law of mass action and interpreting the results from that number. Remember, it's a ratio between the concentration of products over reactants, and that ratio determines if you get more products or do you get more reactants. So hopefully this video has helped you. So check out the next one when we talk about the calculations using ice tables.